Hi, this is Chris, and we are taking a look now at graphing a log function when we have a couple translations in place. So our original log function f of x equals log x is shown on the graph here. And then we're being asked to graph a different function, g of x, which is going to be based off of that same parent function, except with a few translations. And here we have an x minus 3 in parentheses and then a plus 1 outside of parentheses. So whenever you're dealing with translations, I recommend using this little acronym HIT, which stands for horizontal, inside, tricky. And this is just my own way of remembering that if you have something inside, so for example inside of parentheses, or it could be inside of an absolute value or inside of a root, but whenever you have something inside, that's going to indicate a horizontal transformation. So horizontal translations are going to be represented inside of a parentheses, and those are a little bit tricky because they work sometimes counterintuitively to the way that people are expecting them to work. So here, x minus 3, you might think minus should be negative, should be in the left direction, but that's actually going to indicate a shift to the right. So this would be a shift right 3. And then our vertical shifts, our vertical translations are actually going to work a little bit more intuitively. When you have something outside your parentheses, like the plus 1 here, that works the way you might expect it to. Plus 1 means up 1. So our graph of g of x is going to be the same general shape as our graph for f of x here, except we're going to shift it to the right 3 units and up 1 unit. And since we have this key point here, and if you looked at our video on graphing logs as an introduction, and we understand the importance of identifying that x-intercept of 1, 0 that we have highlighted there, that's the point that you can use to apply these corresponding shifts to. So if we go right 3 units, 1, 2, 3, so it would be at 4 for x, and then we go up 1, so up 1, 1, that would be at 1 for y. So this is going to act basically as our new x-intercept here. So we're going to have this same general shape to our graph that's going to pass through that x-intercept, and then it's going to have an asymptote here at 3, and then it's going to continue rise as x approaches infinity for that. So that would be the basic way to apply these shifts to our parent function of f of x equals log of x. Stay tuned for more and check out more log graphs in our next video. Thanks for watching.